Hello, everyone. My name is Hassan Raza, a software engineering student at Air University Islamabad. Today, I'll walk you through my statistical analysis project on the Global Terrorism Database, or GTD. Over the next few minutes, I'll explain the objectives, methodology, and insights derived from this analysis, followed by a brief look at the code implementation. The Global Terrorism Database is a comprehensive open-source dataset that documents terrorist incidents worldwide since 1970. It includes detailed information on perpetrators, targets, tactics, and outcomes. The primary goals of this project were to analyze terrorism data from 1970 to 2020, to uncover trends and patterns, understand regional distributions and attack categories, and provide actionable insights to mitigate terrorism's impact. The dataset comprises over 209,000 records with 135 attributes. The first step was data cleaning, handling missing values in critical fields like fatalities and injuries, and focusing on relevant columns for the analysis. Statistical methods were then applied to explore patterns in terrorism incidents, casualties, attack methods, and regional impacts. Visualizations were created using tools like Matplotlib and Seaborn to enhance understanding. Now let's discuss the major findings. Bombings and armed assaults are the most common attack types. Private citizens and property are the most frequently targeted groups, highlighting the widespread human impact of terrorism. The number of incidents peaked in 2014, but has been declining since 2015, with South Asia and the Middle East remaining hotspots. These insights reflect terrorism's regional and societal impacts over decades. A closer look at the past decade reveals peak activity in 2014, followed by a steady decline, potentially indicating the effectiveness of counterterrorism measures. Interestingly, Afghanistan, Iraq, and India are among the top countries affected, reflecting ongoing conflict and instability. Meanwhile, emerging threats in regions like sub-Saharan Africa, particularly Nigeria and Somalia, demonstrate the evolving nature of terrorism. The visualizations created during this analysis, including bar charts and frequency distributions, provided clear patterns in casualty data, regional impacts, and trends over time. These graphs made complex data more accessible for interpretation and reporting. In summary, this analysis successfully cleaned, transformed, and visualized the dataset, uncovering trends and actionable insights. The project not only highlights the human cost of terrorism, but also provides a framework for using data-driven approaches to analyze global issues. Now let's look at the code implementation in Jupyter Notebook. In this project, Python was used extensively for data cleaning, transformation, and analysis. Libraries like Pandas helped pre-process the dataset, while Matplotlib and Seaborn were used for creating visualizations. For example, missing values in critical fields were replaced with mean values. Date components were combined into a single date column for precise temporal analysis. Casualty data was categorized into bins for better grouping. The statistical analysis included measures of central tendency, variance, and advanced metrics like skewness and kurtosis. These calculations provided deeper insights into the data's distribution. The final step involved exporting visualizations and aggregated data, which were then used for creating the presentation. This integration of statistical techniques and data visualization tools demonstrated how effectively data can be used to uncover valuable insights. And that concludes the walkthrough of this project. Thank you for your time, and I hope this inspires you to explore the power of data analysis in tackling real-world problems.